Hi, I'm here with Josie Bolotski, the coding mentor on Team 4682. So first off, what was your background and what did you major in?
My background is a little strange because I'm not currently working in the area that I got my degree in. Um, so I got my degree when I went to college. I didn't really know what I wanted to do, and I just knew that I was kind of good at math. And I came from an area where there weren't a lot of people who worked in tech, and so I didn't really know what that meant. And so I went to school and started majoring in math. Um, but then I saw all these other people doing really cool other engineering stuff. And so I thought that looked more fun. And so I started taking classes in computer science and ended up getting a undergrad degree in computer science and electrical engineering with a minor in math. And then I did my master's degree in electrical engineering and computer science. And then I decided for my PhD that I wanted to do pure electrical engineering. So I did my undergrad and master's at MIT, and then went out to Berkeley to do a PhD in electrical engineering, and I focused on low power circuits for wireless communication. And this was in the time when, before smartphones, the very early days of cell phones. And so when I was thinking about what I wanted to study, I was really thinking about what technologies were going to be really important to the future of tech. And at the time, I thought that low power circuits and wireless communication would be a really good combination because anybody who needs a wireless device needs it to be low power.
After college, what was your first job?
I had a lot of jobs in college. So it was in Central California, or the Bay Area of California, and it was the late 90s, and so there were a lot of startups. And so in grad school, I worked for a lot of startups while I was getting my PhD. My first job out of grad school was a professor. Actually, I became a professor at the University of Washington in electrical engineering, and I stayed there for about 2 years. And then I decided I didn't want to be a professor anymore, and so I went into industry and got a job at another startup doing wireless chipsets.
And what's your first engineering job?
Um,
Was the chipset your first engineering job?
no, I had a lot of engineering jobs before that. So I had a lot of jobs on campus, actually. I did research on campus. So I think probably my first engineering job was doing research as an undergrad, doing research in a graduate student lab. And that was doing something called reversible computing, where we were building circuits that you could reverse. And there's a whole bunch of physics and thermodynamics and circuit design involved in that. It was a really cool project. My first job with a company was an internship that I did in my undergrad, and that was with Hewlett Packard Medical Division, and I worked on algorithms for ultrasound machines.
Okay. And what is your current job, and what's a typical day look like for you?
Yeah, so my current job is funny because I'm semi-retired. So I decided very early on that I would kind of work really hard and save a lot of money and then retire early and then spend the second half of my career giving back. And so now I work for part-time for a nonprofit. I also mentor the FRC team, and I do a whole bunch of other kind of related stuff to tech and tech education. But my last job was at Amazon. I was at Amazon Robotics, and I did computer vision for the robots. So essentially, we used cameras so that the robots could see what they were doing. And my job was to build algorithms that would take images from those cameras and figure out what the robot should do. And it was based on AI.
And are there any interesting things being done in that field right now?
Well, I think everybody's heard about ChatGPT.
Yeah.
I would say that there's a lot of other cool AI besides ChatGPT. So I would say don't get too focused on ChatGPT and look around for the other kinds of AI that are being done. Specifically, AI that are solving real problems, real business problems. So one of the startups that I work with is using AI to grow food. And I think that's a really cool application of AI. The AI isn't as cool as maybe ChatGPT from the AI perspective, but it's a more simpler AI and it's actually solving a real problem for the world. So I think the applications of AI are more interesting than the AI itself.
I know you're not your current job, but how much did you use your major in your old job at Amazon?
Yeah, I used my major in all of my jobs. So I was always what's called an individual contributor. So I was always doing engineering. And in the early part of my career, I was doing chip design almost all the time. And so that was directly related to most what I studied in school was circuit design. As technology evolves, you have to keep up with the technology. So you learn new things and you apply it. But all of the basis that I said in my undergrad, master's, and PhD were used in the first 10 to 15 years of my career. In the second half of my career, when I started moving more towards machine learning, I used more of the math part of my degree, which was some of the earlier stuff I did when I was a math major and math minor.
Yeah. And what was your favorite part about your job? Or maybe least favorite part about?
Yeah, my most recent job at Amazon, the most favorite part of my job was doing things that would impact a lot of people. So I built robots for the fulfillment centers, and one of the earlier robots that I built moves packages through the warehouse to make sure everybody can get their packages on time. And one of the really cool things about working at Amazon is that the scale is just so big. Amazon's a worldwide company and they process billions of packages. And so at some point last year, the robot that I helped design picked its billionth package. Wow. And so I find it really fun to do things that just have such a big impact.
Mm-hmm. And do you think if you're going to go to college, you'd major in something different? Again.
Yeah, so I'm the kind of person who gets bored if I do the same thing for too long. So I did circuit design for a while, and then I did AI for a while, and now I'm retired and doing different things. I think I would have just chosen something different to choose something different. I really like to think about what are the technologies that are going to be important over the next 10 years. And I think probably nanotechnology sounds really fun. I think biotechnology sounds really fun. So, I mean, I just really like technology and engineering, so I probably could have majored in anything and been happy.
So what other things did you do in college that you loved?
Well, I had to work a lot, so I didn't have a lot of free time, but I did do some sports, and I really loved that because it kind of, when you're doing a lot of engineering work, it's very intellectual and you're sitting down a lot. So it's good to get up and move your body. And so my freshman year, I rowed crew. And my sophomore year, I didn't have time to row crew anymore. But I did switch to playing intramural ice hockey, which was a lot of fun.
Do you have a memory in particular, like a moment?
A moment in undergrad that was
anywhere in
like
college.
Technology related or not technology related?
Anything.
Okay. Yeah, I mean, my senior year project, I was working with a graduate student, and he was building a fully reversible computer. And it's interesting because you can run the computer forward, and it drains the battery. And then you can kind of flip a switch, and it runs the computer backwards. And it recharges the battery by undoing all the computation that it just did. And it's kind of a thing that won't ever become a product or won't ever impact the world, but by building it, we proved it was possible. And so that was kind of some of the most kind of theoretical work that I did. It dealt with physics and thermodynamics, and that was my first taste of working with a research team on something new and really pushing the boundary of something. And so I think that's one of my earliest, proudest moments.
And quick question, why wouldn't it be applicable?
So when you do reversible computing, in order to have it be fully reversible, you have to compute very, very, very slowly. And so if you wanted to compute something real, it would take way, way, way too long.
Okay. So fresh out of college, what do you think a typical entry-level job looks like?
Yeah, so I can just talk about some of the jobs I had in college or freshly out of college. You're generally working on a small part of a bigger project. And you usually have senior engineers around you who are kind of teaching you the ropes. So you have a lot of theoretical knowledge or maybe even some practical knowledge from your undergrad, but there's a lot that you don't understand about how to really design a product that's going to be robust and reliable and maintainable. And those are all aspects that, people who've been in the industry a long time can really teach you. And so you usually get something that's well defined and then you're working on it. So for example, I might get a senior engineer who's designed a circuit and I'm doing the layout, or a senior engineer who's kind of designed a function, and then my job is to translate that into circuits. And similarly with code, on coding projects, you might get a well-defined piece of code that has kind of well-defined inputs and outputs, and you're just kind of doing the piece in the middle, or writing tests or debugging. You might sit in on design reviews and see how the senior engineers think and build bigger things so that you can get some experience that will help move you forward.
Right. And are there any traits or experiences you look for in new hires?
Yeah. So I want someone who wants to work hard. I think sometimes people get allergic to hard work, but I feel that if you're going to do something really interesting and hard and is going to push the boundaries, you got to want to work hard at it. And I really think that the things that I'm most proud of are the things that I work the hardest for. So I'm definitely not allergic to good hard work, and I want to find teammates who also want to work hard. I look for people who have a really solid foundation in the basics. Making sure they know their fundamentals. But then I'm also looking for a good team player, somebody who communicates well, and somebody who's a little bit creative. Yeah. So I like to see people who have, not just narrowly focused on one thing, but have some interests either in technology outside of their main thing or interests outside of, technology in general. I think that to push the boundaries of technology, you need to have some creativity.
Mm-hmm. And do you have any favorite STEM memory in your entire life?
I have so many. I think one of the memories I have is I participated in, I worked at Qualcomm during the early days of the first smartphones, mm-hmm. when Apple was coming out with the first smartphones. And some of the chipsets that we developed at Qualcomm went into those phones. And it was a really interesting time because before then, people had only expected people to use cell phones for voice calls. And everything from the interface and the chipsets in the cell phone to how we transmitted data over the air was all geared towards voice calls, mm-hmm. and a little bit towards texting. But then Apple came out with a smartphone and we had to really completely rethink everything about how we transmit data, so in packets rather than streams. And we also had to rethink about power consumption, because now people wanted to do all sorts of things on their phone and they wanted the battery to last all day long. And it was really challenging in those early days to think about new use cases like web browsing or GPS, putting your phone in your pocket and going for a run and figuring out how we were going to make that battery last all day long. And so I participated and led, along with hundreds of other engineers, a really focused effort on power reduction for cell phones. And we made some amazing strides in those early days to make cell phones actually usable and not last just a couple hours on a battery.
Yeah. Is there any other parting advice you have for someone pursuing a STEM career?
Yeah, so one of the things I see in young people who are just coming out with a degree is that the degree is not enough. The degree is kind of the prerequisite. It says that you know the basics and that you know how to work hard and work through the system. But you always need to show how you're applying that technology. So I think the kids who are going to do best are the kids who have some kind of passion project or took their senior project and did something really interesting and above and beyond with it. I think also people who are reading about the general tech industry and following the trends and understanding what are going to be the next cool technologies and reading up on them and being in the know. I think it shows that they're interested in learning, and the tech industry is always moving. So in order to do well at it, you have to always be learning.
Yeah. All right. Well, thank you very much for your time.
Yeah, you're welcome.